Okay, let's quickly review a few basics when it comes to scientific notation. A lot of people see this in science classes and math classes, and sometimes they get some patterns down, and sometimes they're not really sure what they're looking at. So let's make sure we know the basics. Okay, scientific notation is basically used when you have really gigantic numbers or really tiny numbers. Now just think about it. If we had to measure, the distance from here to the sun, that's a really, really big number. If we had to measure the width of a contact lens, that's a really, really tiny number. Rather than writing decimal points with a whole bunch of zeros, we're going to find a way to put this into something that's a little bit easier to see and compare to something else without having to count all the zeros and make sure we have everything written perfect. So scientific notation has its purposes. It's usually for gigantic numbers or tiny numbers, but anything can really be written in with this format. Okay, so if we see a number that's written in scientific notation like the one here in red, this number right here should always be between 1 and 10. And what that really means is the decimal point needs to be after the first non-zero number. Okay, so 3.21 times 10 to the 7th. Okay, this 7th right here is telling me how many powers of 10, or essentially how many places I have to move my decimal point. But the fact that this is a positive number tells me I have a big value. Okay, positive exponents means big numbers. So how can I make 3.21 a bigger number? Well, I can move the decimal point to the right. Every time I move to the right, it gets bigger by 10 times the amount. So what I'm going to do is I'm going to take the decimal point and move it 1, 2, 3, 4, 5, 6, 7. Now I know I kind of went across this and there's other stuff in the way, but let's pretend that other stuff isn't there and put a 0 in everywhere we moved it. And what that leaves me with is 3, 2, 1, 0, 0, 0, 0, 0. I have 32,100,000. That's what this number represents, but it's written in scientific notation. Now let's jump over to this green one. The fact that I have a negative exponent tells me this is a tiny number. It's not big at all. Negative exponents being really small. It's smaller than 1. Okay. So how am I going to make 7.29 a smaller number? Well, I'm going to move the decimal 3 places, but I'm not going to worry about left or right. I'm going to say which direction would make this a small value. And that answer is this way. I'll move it 3 spots that way and put zeros in every gap that I skipped over. So my answer to this is 0.00729. Notice that's a really small number. Small number, negative exponent. Big number, positive exponent. That's all we need to know. Now let's look at going the other direction. Okay. So if we look below this, 485,100. Okay. Is that a small number or a big number? Well, that's pretty easy. That's a big number. It's a lot bigger than 1. Where's the decimal point on it? Well, the decimal point is right here. Even though it's not written, it's right there at the very end. Now to write in scientific notation, I need the decimal point to be right in here, after the first non-zero number. So I'm going to have to move it 1, 2, 3, 4, 5. So I'm going to write this as 4.851. And then I got to remember, my original value was huge, very big number. So I'm going to write times 10 to the positive 1, 2, 3, 4, 5. I'd move it 5 spots. Okay, that's a positive exponent because it's a big value. There's scientific notation. Now let's take a look at the other one. This is a tiny number. That means I'm going to have a negative exponent. Now let's see how far we have to move it to get our exponent to be behind the first non-zero number. 1, 2, 3, 4, 5, 6. So my answer is 5.3 times 10 to the 6th, but I want to make sure I show that this is a small number, so I'm going to say it's negative 6. Negative exponents, tiny numbers. Positive exponents, big numbers. And there's our basics for how to interpret scientific notation.